Hi everyone, welcome to an introduction to notebooks. To give you a little background of what you will be doing is we will be connecting different habitat patches, i.e. public lands, to one another via the least path corridor. So our study region is the St. Croix River watershed, and we want to be able to connect this is located outside of St. Paul and Minneapolis. So what we want to do is connect different public lands to one another and find the path of least resistance. So essentially what we are doing is using a raster grid, assigning a value to each cell, and the ArcGIS tool finds the least cost path from one point to another. And in order to do this, we will be using the cost connectivity. And I highly recommend checking out some of the documentation on ArcPro to elaborate on what we will be doing. And so this is just kind of a quick overview. And we will be using notebooks to perform our analysis. So one of the powerful things about notebooks is being able to find studies and research that is open source and already done. And so for this example, I am not even going to try and say that name, Thornweight Mather procedure for groundwater recharge. And this is open source. So we were able to copy this and change the variables to fit our study of interest. So I'll go ahead and run this so you can kind of get an idea of what we will be doing. And so this is the formula that we will be using. So instead of having to research this and try and replicate it on our own, we are able to access open source notebooks that allow us to perform complex analysis and provide us with different insights into our data. So I've already changed some of these variables to fit the study of region, and I'm just going to scroll through here and run through the notebook. Many notebooks are similar in this, and so they'll have your comments above and then your snippets to run, and we'll just keep working through the notebook. And leaving yourself good notes will help you reproduce anything. So this snippet gave us our first map, and as you can see, this is imagery from Google Earth Engine. So this is open source to everybody. And what we're interested is in groundwater recharge. So we'll keep working through this open source notebook, and we are able to get our properties at different soil depths. So once again, this is from open source data, and we can continue to use the formulas that these researchers have already provided for us. I'm just going to continue to work through the notebook just so you get a feel of what we're doing. And so right now we're just working through the different layers and configuring the data to how we need it. So now we have our hydraulic properties at different soil depths. And once again, I changed this, was originally for France. However, I changed the input variables to match the study region. So if you wanted to, you could take this notebook, change your input variables, and do a water recharge estimation on your area of interest. And notice in notebooks how after each cell is run, we get a number of our steps of process. This can help you keep track of where you're at in working through the notebook. So we're just going to keep on working through, and each little notes section is telling us what we're doing in each snippet. And as you can see, this is quite a long notebook, and so we'll only do a couple more cells. I think you guys are getting the idea of what's going on here. And so now we're looking at precipitation versus transpiration. And so now we have a time series from 2015 to 2019. And so let's go ahead and I will show you a notebook that I created myself. And once again, using all open source. So I chose a USGS layer, and I'm selecting the St. Croix. And then I want to collect the USDA crop layer and filter our date. Now we're getting the NAIP imagery. And this one is MODIS collection. And now we're going to create our first map. So we now have a map that we can put on the internet or use for our own analysis. And so we have our NIP layers, our cropland layers, and our boundary layers. And we're able to start doing our analysis on our watershed using open source maps and open source data. So that's the end of the introduction video. Go ahead and start the next video, and we will work with notebooks in Arc Pro.